Jennifer said record, Naomi. Okay, here we go. Today's lesson is different than the last ones because in the first two, 10.1 and 10.2, we were just simplifying one radical setup. Today, we're going to be adding and subtracting different radical setups. So you're going to do some of the simplifying that we did in 10.1 and 10.2, but then once you've done that, then you'll add and subtract things together. You can go. All right, so here's what you're going to do. Step 1 is the stuff you already know how to do from 10.1 and 10.2. Okay, you're going to simplify your radicals. So you start with what we did in 10.1 and 10.2, and then we're just going to tack on an extra step or two to that. Then you're going to identify radicals that have the same index. Do you remember where the index is? It's this one, right? The index. So if it's a 3, that's a cube root. If there's nothing there, it's the square root, okay? So those have to be the same, and the radicand, what comes under the radical, have to be the same. You cannot add and subtract radicals if those two things aren't the same. Okay, so if they're different, you're done. You leave them alone. When they are the same, then you're going to add and subtract the coefficients. What's a coefficient? Same type of number. It's what comes in front of. Usually it's a variable that it comes in front of. This is going to be a radical that it comes in front of. So the coefficient, like if it was 2 rad 7, your coefficient is the 2. Okay, the numbers that come in front. The radicals are going to stay the same. It's kind of like saying 2 apples plus 7 apples is 9 apples still, right? That radical should stay the same. So let's take a look and see how this goes. So your first step is simplify the radicals. So you have rad 20 and you have rad 5. Can you break rad 20 down into a simpler setup? Yeah. You totally can. So if we break this down, you have that negative 2 out in front. What perfect square is 20 divisible by? 4. So this is going to be a 5, and then minus, and then you have a 2 rad 5. Can you break a rad 5 down? That's as simple as it can go. So you're going to go like this. Negative 2 times 2 times rad 5 minus 2 times rad 5. What do you think you simplify next? Multiply. Negative 2 times 2 is negative 4 rad 5 minus 2 rad 5. So now the beautiful thing is we have identical radicals, rad 5 and rad 5. What are your coefficients? Negative 4 and negative 2. Those are the parts that you can combine. The rad 5 is going to stay put. So you're going to go like this. Negative 4 minus 2 equals a negative 6, but your rad 5 stays put. Okay? Negative 4 apples minus 2 apples is negative 6 apples, which doesn't make any sense, but hopefully you get the concept. It's kind of like terms, right? If it was 2x squared plus 3x squared, you would make it 5x squared. You're treating your radical as the like term part of it, okay? Questions on that setup? Okay, look at number 1. It says find you sum or difference. Make sure you simplify first. Is there anything you can simplify with rad 6 and rad 6? That's as simple as you can go with those radicals. So then you look at your coefficients. 3 rad 6 minus 2 rad 6 is what? 1 rad 6. Now, the 1 doesn't change anything, so you can just write that as the square root of 6. If you put the 1 in, I don't mark you wrong. It's totally fine. But you're just taking 3 minus 2. Leave the rad 6 as rad 6. So what do you get on number 2? 4 rad 5. The rad 5 stays the same. You cannot go rad 5 plus rad 5 equals rad 10. That's not how radicals work. It's like saying 1 rad 5 plus another rad 5 is 2 rad 5s, okay? So now it's 2 rad 5s plus 2 rad 5s equals 4 rad 5s. Okay? Questions on that? Okay, those two are like as simple as they get with this stuff. There's nothing to simplify first. You just add and subtract. Where it gets a little bit fancier is when you get to a problem like this. Here's what I want to point out to you. A lot of the time, you should be ending up with the same radical so that you can combine things. It's not going to happen every time, and I'll show you situations where it doesn't happen. But if you're like, I have no idea what to break 63 down into, this often is a clue for you, because likely you will be able to add rad 7s in the end. So if you're like, I don't know what 63 is divisible by, that's a perfect square. We know that rad 7 is not a perfect square, so put that on the right side. What can you multiply 7 by to get 63? 9. Is that a perfect square? Mm-hmm. So if you don't see it, you could look to the other number and see if it works with that, okay? Okay, so this is, there's a 2 out in front here, 10 rad 7 plus 2 times rad 9 times the rad, times rad 7. So you are going to do 2 times 3 times the square root of 7 plus that 10 rad 7. So it's 10 rad 7 plus 6 rad 7. And I'm showing you every single detail all along the way. When you get to here, if you go, oh, I know that's 6, I don't have to see this middle step. But if it makes more sense for you to break it down one little piece at a time, then do it, okay? It's better to get it right than to rush through it. So take your time, show your work. What does this become? 16 rad 7, not rad 14. Don't add the radicals together. Add the coefficients together. Okay. I want you to try number 5. Number 5 is for sure the most involved that we've seen so far, because both those radicals are going to get broken down. So give that a go and see if you can figure out what numbers that becomes. So what did you break down the square root of 32 into?
16 and 2.
Right. Okay, so I saw a lot of people trying to do 8 and 4. Can you do that?
Yeah.
Absolutely. You're going to do more work than your neighbor who did it this way, but you totally can. You just have to keep breaking it down until you can't break it down anymore, which is why I always say start high. What did you do for 18?
2 and 9.
Okay. Here's if you're not sure what to do here, take the smaller number and break that one down first. 9 and 2 is going to leave you with a rad 2. So then go over here. Would it make sense to have a rad 2? Well, 32 divided by 2 is 16, which is a perfect square. So sometimes it's easier to kind of work backwards if you can't find the number. Okay, so then you do this. 2. This is multiplication in between them. So 2 times 4 times the square root of 2 minus 3 times 3 times the square root of 2. That's 8 times the square root of 2 minus 9 times the square root of 2. And then you can do the coefficients. 8 minus 9 is negative 1 rad 2. That's the same as saying negative rad 2. So either one of those, you don't need both. They're the same thing. Pick one or the other. Yes?
So now it's like 2, like you like did 16 and 2, then 9 and 2.
Mm-hmm.
If you get like, let's say you don't find a common number like 2, what do you do then?
I'll show you. We're going to do that next. Any other questions? Okay. Go to number 11, and we'll do exactly what we were just saying. Okay, this looks a little fancy, right? It's not that fancy. You're doing the exact same thing, just 3 times instead of 2 times, and then you got to stop and look at what you're left with. What can you break the square root of 50 into. 10 and 5 doesn't have a perfect square though, right? 25. And don't forget about your friend out in front, that -3. So that plus, okay, now the 18. What can you break that into? 9 and 2. Okay. Minus, and then we've got 3 rad 3. Okay, so simplify what we have here. This is -3. What operation's happening between the -3 and the rad 25? Multiplication. -3 times 5 times the square root of 2 plus 3 times the square root of 2 minus 3 times the square root of 3. What does this become? The pink underline. -15 rad 2 plus 3 rad 2 minus 3 rad 3. Okay, so our radicals are simplified. What do you notice? This one's a rad 3. These ones are rad 2s. You may only add them if their index is the same, right? They're all a square root, so all of these indexes are the same. So that's the first step. Yes, we could add them all. And they're radicand. Well, this is a 2, this is a 2, this is a 3. So no, we cannot add them all. But you can add 2 of them. You can combine those. So -15 rad 2 plus 3 rad 2 is what? -12 rad 2 minus 3 rad 3. There is nothing else you can combine about that. Don't combine that -12 and -3 because they don't have the same radical. You have to just be done. Okay?
So if that 3 was like a 4, then you could like make it a 2, then it would work.
You can't combine them then. Like if this is not the actual problem, but say it was -12 rad 2 minus 3 rad 4. That would be -12 rad 2 minus 3 times 2, so minus 6. That has no radical, and you can't combine those if they're not identical radicals. Okay? Okay, last one. Do you want to try it on your own first? Number 13. See what those break down into. Remember, start high and work your way low. You can check if there are some that you could get the same radicals for, but I promise they won't all be the same radical.
Yeah.
30 points during the season. Season.
What did you get for an answer?
20 rad 2 plus 6 rad 5.
20 rad 2 plus 6 rad 5. Yes? Okay. Here's how it goes. Square root of 4 and square root of 2 with a -5 out in front. Really, what gets forgotten the most is those numbers in front. So just make sure you're taking those numbers with you. 9 and 5 gets you 45. And then 200, the perfect square would be 100. The non-perfect square would be 2. So this is -5 times 2, so -10 rad 2. This is 2 times 3, so 6 rad 5. And then this is 3 times 10, right? Square root of 100 is 10, so 30 rad 2. And now you can combine these two, because they're both rad 2s. You can't do the 6 rad 5. So -10 plus 30 is 20 rad 2 plus 6 rad 5. Did anyone do 6 rad 5 plus 20 rad 2? That's okay too. It's the same answer. What you can't do is swap them if it's subtraction. Okay? But that would be the same. Hey, I know him. Questions? All right.